if that innovative idea doesn't pan out and you lose some money on it, your career is permanently damaged. And a lot of managers in the corporate world don't feel like they want to take that risk, particularly since typically there's no penalty for not taking it.
Hello and welcome to the Being an Engineer podcast. I am so excited today to be speaking with Steve Hinch, a seasoned high-tech executive, award-winning author, and innovation consultant. With senior leadership roles at Hewlett-Packard, Agilent Technologies, and TeamLogic IT, Steve brings decades of experience driving both incremental and disruptive innovation. His latest book, Winning Through Innovation, distills lessons from a career spent on the front lines of R&D, marketing, and general management. Thank you so much for being with us today, Steve.
Thanks, Lottie. I appreciate it.
So, what made you decide to get into the field of technology and engineering and innovation?
Well, I'm actually probably one of the few people I know that figured out early on I wanted to be an engineer. And up until I went into high school, I had always thought I was going to be a paleontologist.
Oh, interesting.
But when I went into high school, the counselor said, we don't have a course on paleontology for you, but we do have a course on electronics that's open to freshmen. And so let's sign you up for that. And I took that. I loved it. I loved it so much that they allowed me to take that course for 4 years, all 4 years.
Oh, wow.
And after the first year, I probably knew more than the teacher. And so I helped being basically a teacher's assistant for all of the younger students that were coming in just learning about electronics. So I knew I wanted to be in electronics engineering pretty much from the first day of high school. And so it was fairly easy to pick a college that was consistent with that objective. And so I went to Harvey College in Southern California, stayed there for both bachelor's and master's degrees in engineering. One of the things about Harvey College is they offer a degree in engineering. It's not a degree in electrical engineering or civil engineering or mechanical engineering. It's it's engineering. And so theoretically, I could be as good an engineer designing bridges as I could be designing circuits. But I did sort of focus as best I could on courses in the electronics area. And I was fortunate enough to get a job at Hewlett-Packard just after I graduated and stayed with HP. And then they spun off into a separate company called Agilent Technologies in the year 1999. And so I had a 35-year career there before I decided to take the entrepreneurial bug and started a small company here in Santa Rosa.
And what's the company that you're doing in Santa Rosa now?
So the company is actually a national company called TeamLogic IT. They provide IT support for small businesses, businesses that don't have their own IT technicians. And so I bought the franchise in Santa Rosa that was not open. I opened the franchise in Santa Rosa, ran that franchise for about 6 years, made it one of the top 3 in the company. And then I sold that. And ever since, the corporate offices, which are located down in Southern California, have been hiring me as a consultant to do all sorts of project-related work because unlike the rest of the people that are running the corporate office, I actually ran a franchise. I know what it's like to be an owner. And they're sort of I would say the consultants that sort of help you, but they've never actually run a franchise themselves. So I bring a perspective to the corporate offices that they wouldn't otherwise have. And that's kept me busy for several more years.
Yeah, I'm sure that's massively valuable to them to have someone with your perspective. Well, you spent a long time in R&D, And a lot of engineers who listen to this show are in R&D or manufacturing, process engineering, but they spent time in the trenches, coming up with the new technology, figuring the things out that just don't exist yet. What not many of our listeners have deep experience in is the other side of that equation, which is like the marketing and the sales aspect. But you also eventually moved into a marketing role. Can you talk a little bit about how that changed your perspective or your understanding of innovation and the engineering process?
Yeah, that was really quite an experience for me, and it really changed my perspective. And I'll get more into that in a minute. But before I do, let me just sort of highlight the 3 or 4 different aspects of my career. I started out as a production engineer at Hewlett-Packard in their microwave test equipment area. So I was not inventing the new products. I was fixing problems on the products that had been invented by the R&D engineers a couple of years earlier, but they were off inventing new products. They didn't want to fix problems on the stuff they'd worked on before. So we production engineers were the ones that took care of that. I was in production engineering for about 10 years, eventually moved into R&D, not as an R&D engineer. I've never been really as an R&D engineer. I moved in as an R&D project manager, and then moved up eventually to be an R&D manager of a whole division. And I always wanted to move even higher in management to run my own business. And at HP and its spin-off, Agilent Technologies, they form several different divisions. A division is sort of the smallest organization that's completely responsible for its own profit and loss. It's typically between $50 and $100 million, $300 million a year business. And I wanted to do that. And I got coaching from my general manager at the time saying, Steve, you've been in manufacturing, you've been in R&D. If you want to run a business, you really need to learn about marketing. And so he was able to get me into probably the only marketing job responsibility that I was qualified for, and that was being the division marketing manager for a $300 million a year business. I didn't have to actually figure out how to go sell products. I didn't have to actually write all of the collateral for selling the new products. I was bringing a higher perspective. And up until then, I'd never served a day in marketing. And my only experience, this is probably going to date me, but you remember the cartoon Dilbert?
Mm-hmm.
And there was one cartoon showing that Dilbert was being sent to marketing, and there was this big arch in front of marketing that says, "Welcome to marketing, 2-drink minimum." And that was my perspective of marketing until I became the marketing manager.
Just a big party, huh?
Just a big party. And that was not it at all. These people, I was responsible for product marketing, for sales development, for Marcom, for product support. There were really sharp engineers there that I had really never given a lot of credit to before. Now, in my role as R&D manager, I had worked very closely with my counterpart in product marketing. So I sort of knew product marketing. They would be the ones that take the new product I was developing and launch it out into the world. So I knew that part of it. But all of the, how do you put together a marketing support program, all of the Marcom collateral. I thought Marcom collateral was all of the stuff, the little freebies that you give away at a trade show. And the Marcom manager always wanted to strangle my neck because that was a very small part of the job that a marketing organization does. But I learned a lot. And I have to say that when I first came in there, everybody in marketing thought, who is this guy from R&D going to be running marketing? And I tried not to come in thinking I knew all the answers. I came in wanting to pull the best I could out of all of the people that were working for me because I knew they knew their jobs better than I did. But I had the higher perspective because I had worked with customers before, selling, going out with the marketing guy when we were launching our new products. I knew that part of the business and I knew how to sort of pull it all together. But it was really an eye-opening experience. And I would strongly recommend any engineer thinking about eventually wanting to move into higher level management, C-suite management, or even opening their own company, that serving time not only in R&D, but also in marketing to learn the ropes of both of those sides of things is very important. Serving time in manufacturing might not be as important depending upon what kind of business that you're going into. Software company, maybe not quite as much, but you're always going to want to know about R&D and marketing.
If you had to distill at a very high level the essence of marketing, especially within the context of an engineering environment, down to just a few words or maybe a short sentence, how would you define marketing?
So I'm not going to be good at distilling it down to a few words, but let me just say 2 points.
Okay.
There's a difference between marketing and sales. I never manage sales. Sales is, those are the hunter killers that are going out closing deals. Marketing is, their responsibility is to get the message out to the customers so that the sales guys can close the deals.
That's a good way of distilling it, getting the message out. I like that a lot. Mm-hmm. In your book, Winning Through Innovation, you talk about turning ideas not just into a reality, but how to turn ideas into a profitable reality. And not everyone gets that second aspect, the profitable reality, right. Why do you think that so many organizations struggle with that aspect?
From motors and robotics to controls, automation, and precision prototyping, Simutech brings ANSYS simulation tools and expert insight directly to your team. We help you accelerate design, reduce risk, and eliminate costly rework.
Validate before you fabricate. Simutech Group helps you simulate thermal stress, vibration, fluid flow, electronics cooling, electromagnetic performance, you name it.
Whether you're in automotive, aerospace, energy, industrial automation, or the next big thing, Simutech partners with innovators to deliver simulation-driven results that move products forward. Build smarter machines, launch stronger products, scale faster with Simutech's simulation support by your side.
Simutech Group, your engineering partner in motion. Visit simutechgroup.com and let's power up your next design.
Okay. So let me first say, not every innovative idea that you have is going to turn out profitable. And that's because, when you start an innovative idea, especially a disruptive innovative idea where you're going to go off into a new market that you've never dealt with before, you don't necessarily know that market. You don't know for sure the technology that you're thinking of is going to work. And so those kind of disruptive innovations may fail over half the time. And that's okay. And I use the word fail carefully there because they're not really failures. They are ways for you to learn more about how you can be successful in the future. The problem with a lot of companies, particularly larger companies, is they don't give the innovative ideas the opportunity to really prove themselves out. If you're not delivering results immediately, it's time to chop it. I just read a post today from the former CTO of Hewlett-Packard, who he spent about $1.2 billion buying a company. It was actually Palm that they bought. And he had a great idea for how to turn that into a struggling company at the time. And he he had some ideas on how to turn it into a company or to a profitable company, but his CEO did not want to wait. Within, I think it was like 60 days after they bought the company, the new CEO shut it down. He didn't give it a chance.
Oh,
And that's the big problem with why a lot of innovative ideas don't pan out, is the C-suite doesn't have the patience to prove it out, to wait and show that it's really going to work. And I had to struggle with that myself. The biggest innovation that I had at HP that actually brought in this was like around the year 2000 when we launched it. And it is a product line still going strong today and has brought in several $1 billion of profit to the company. But I almost wasn't allowed to do that innovation because it was a disruptive innovation that they didn't know how to structure the organization. But fortunately, the vice president in charge of test and measurement at the time said, what we're going to do, Steve, is we're going to treat you like an in-house startup company. We're not going to hold you responsible for monthly profits, monthly revenues until you launch the product. What we're going to do is we're going to measure you on, are you meeting the deadlines, the commitments that you said you were going to in order to invent this new product? And it took me 2 years to launch that product. But if I had not had that kind of support from the vice president of the company, it would have never happened.
Ideas really just need time to find their way and grow on their own, right?
Mm-hmm.
Can you talk about what that product was, that product line?
Yeah. So I was responsible for R&D manager for the high performance oscilloscope business. And you don't need to know a lot about an oscilloscope, but hopefully your readers have at least used oscilloscopes before. An oscilloscope measures electrical signals, and the ones that I was responsible for had bandwidths up to about 50 gigahertz at the time. That was really, really wide bandwidth. And there was this new market called fiber optic telecommunications that had a need for measuring waveforms, but they needed to measure the waveforms of an optical signal going down a fiber optic cable, not an electrical signal. But so the oscilloscope would have been the great way to do it, but oscilloscopes measure electrical signals. And so people had already put little optical converters on the front of oscilloscopes and were using that as sort of a crude way to make the measurements. But it wasn't fully calibrated, and the standards for the industry were just starting to evolve for saying this is how good the measurement needs to be. And we had this brilliant idea of not only putting that little optical converter inside the oscilloscope, which would have not done very much different than what they were already doing, but to develop a completely calibrated process to make sure that when you're making the measurement, you knew that it was very accurate measurement. And that was something that nobody had done before. You could sort of make the measurements, but they weren't very accurate. At the time, HP had only 25% market share. And our biggest competitor was Tektronix with about 75% market share. And we had to invent this new product in a way so that Tektronix did not find out what we were doing. Because if they did, they would have gone off and invented their own product. And since they were already the market leader, they would have maintained their market leadership. So one of the things I did is we invented what I'll call a phantom product that was not a very good product at all, but we leaked it out to the world, and Tektronix found out about it and said, well, that's not anything to worry about. And they completely ignored us until we launched our product 2 years later. And it took them several years to respond. And by then we had completely swept the market up.
Oh, that's phenomenal. Wow. What a great strategy.
It's not the kind of thing you'll read about in other books on innovation, but I talk all about it. That's just one of the things that we did that made our product successful there.
Talk a little bit more about that. Why was the decision made to leak a phantom product that would be seen by your competitor as not dangerous to them, not a threat, versus just not saying anything.
Good point. And so we did not primarily invent this phantom product in order to fool Tektronix. We needed a way to go out and talk to customers to find out what they really are doing and what they really needed. Now, since we didn't have much market share, they were all buying products from Tektronix. They did not want to talk to us about it. But by bringing out this, what I'll call a phantom product, it was actually, we sold some. It gave us an excuse to go out and talk to customers that otherwise would not have talked to us. And we got to find out what they really wanted. And yeah, those customers said, yeah, no, this is not really very good, but it's maybe a little better than you got right now. And so we didn't deliberately try to leak that information out to Tektronix. That just sort of leaked out because the customers would go back to Tech and, yeah, we just saw this new product from HP. You have nothing to worry about. So anyway, so that was really why we did it. It was not primarily to fool Tektronix.
That's hilarious that it had that unintended side effect. How funny. Okay. How smart do you think people need to be to develop disruptive innovation? Is this reserved only for the cream of the crop, the top 1% of intelligence out there?
If it were, we would have no innovations out there. So, I mean, you have to, there's a couple of parts to this. One is you have to have the innovative idea. In my book, I only touch on how to come up with the innovative idea sort of peripherally because there's not a process that I can really quote for saying, here's how I came up with this idea. What I can do is map out an environment that allows people to nurture those innovative ideas, but the actual idea, the light bulb coming on over your head is not something that you can really map out a prescriptive process for how to do that.
What does that environment look like?
So there's different environment depending upon whether you're doing disruptive innovation or incremental innovation. And let me just quickly summarize the difference between the two. Incremental innovation is where you make minor improvements to your existing product line. And example, the automobile industry, the gasoline-powered automobile industry, have been doing incremental innovations for years. You know, the cars that they sell today sell to the same customers as they sold 10 or 20 years ago, but they're not exactly the same cars. They've got, anti-lock brakes. They've got crash protection. They've got improved warranty periods, but they're still familiar to the people that bought cars 10 or 15 years ago. And they're happy to trade in their old cars for new cars that they see are better. That's incremental innovation. Disruptive innovation, the prime example I use in my book is from the middle of the 20th century. The early part of the 20th century, up until about 1949, almost all the locomotives that the railroad industry bought were steam engines, steam locomotives. By the 1950s, they were all diesel-powered locomotives, and not a single manufacturer of steam locomotives survived that transition because it was such a disruption. They were trying to make better steam locomotives when the industry was already saying steam locomotives are passé, diesels are much better, they're more reliable, less expensive to operate. But so sort of a long way to get to the question you were asking. Incremental innovation is typically best done by the people who are managing that product line. So the managers that are managing the automobile manufacturing, it's time to put a better anti-lock brake in or improve some other aspect of it or put a flat panel display on the front panel. Those are all incremental innovations. The business managers leading that business are the ones best able to do those kind of incremental innovations. But for disruptive innovations, those managers are trying to preserve the product line they already have. They're not going to be the ones to switch from steam locomotives to diesel locomotives. So you really need to manage that disruptive innovation under an organization that's completely separate from the current product line. And that doesn't need to be a giant organization. In fact, generally you staff that with just a few key people. And then as you prove the technology and as you start getting more customers, you can add more team members and start doing more product development. But you want to start that disruptive innovation slowly, and a small part of the market first, to prove that your technology is working and that there's really a market need for it. And then as you capture that small part of the market, you can expand into other parts of the market and take over from those people who are still trying to sell steam locomotives.
That's a great analogy, the steam to diesel locomotives. What have you done to create a culture where everyone feels equally empowered to participate in the innovation process?
The Product Development Expo, or PDX, is your chance to learn from subject matter experts providing practical, hands-on training for dozens of different engineering topics. GD&T, Advanced Surface Modeling, DFM, Plating and Finishing Techniques, Programming Robots, Adhesive Dispensing, Prototyping Tips and Tricks, and lots more. PDX happens October 21st and 22nd in Phoenix, Arizona. Learn more at pdexpo.engineer. That's pdexpo.engineer.
So I actually, if you don't mind, I'm going to pull up my book because I've got 6 things to do to encourage people to innovate.
Great.
The first thing that they need to be able to do is the employees need to understand the company's business strategy. That's the responsibility of the company leadership, C-suite, to explain what this company is all about, what we're trying to do, what markets we're trying to go after, where we're putting our priorities. Because if the employees don't understand that, they don't know where to go off and innovate, or they may come up with great ideas for something that has nothing to do with this company. Now that maybe means those employees should go off, start their own company. But the first thing that really needs to happen is that employees need to understand what this company is all about and what the strategy is. Number 2 is employees have got to understand that innovation is more than just ideas for new products or services. I mean, not every innovation that you come up with is going to be the next Tesla or SpaceX or iPhone. There are going to be lots of smaller innovations that will be just as valuable to the company. And those are the kind of innovations that people lower in the organization are more likely to have the ability to contribute to. You know, the next iPhone is not going to be invented by some first-level engineer down in the trenches, but that first-level engineer or even the people on the production line that are building products may say, this process is not the most efficient way. If we could just change this, I could build 10 more products an hour. And that's the kind of insight that the C-suite is not going to know. They're going to need to depend on the people in the trenches to bring that kind of insight into the organization. Now, once those ideas come up, then you got to give people time to explore those innovative ideas and test them out and try them. And you've got to provide employees with resources to do that. Now, when I was the general manager of the oscilloscope business at HP, I tried to make sure people understood that I felt comfortable giving people about 5% of their work time to explore innovation in ways, new ideas that may or may not pan out, but, take 2 hours a week to test things out. And if it looked like something was going to work out, then I would figure out a way to staff a full project about it. But those innovative ideas, giving people time to explore those innovative ideas and some resources, space or materials to test things out, is really important to encouraging that culture of innovation.
Are you familiar with flaming hot Cheetos?
Tell me about them.
This sounds like a complete tangent, but I promise it's not. So, Cheetos, right? Like the snack Cheetos. I can't remember exactly when it was, but 15 years ago, whatever it was, a factory worker who was Hispanic and felt like the Cheetos didn't resonate with his demographic, the Hispanic population, thought there needs to be a spicy version of Cheetos. And he approached management about this, and they kind of poo-pooed the idea, didn't think it was relevant, and said, no, we're not going to spend anything on this. Well, this guy, he was a factory worker, right? Just like a lowly factory worker. Mm-hmm. And he believed strongly enough in his idea that he spent his own time and resources testing and doing user groups within his community and trying different recipes and putting the spicy, the flamin' hot on the Cheetos. And I think it took him a while, a year or 2 years, something like that. But he eventually came up with a recipe that he really liked and his community really liked. And he somehow finagled his way into getting a prototype run of these flamin' hot Cheetos, and they just crushed it. They did so well. Yeah. And now these flamin' hot, Cheetos, Doritos, Funyuns, they're all over the marketplace. But it was just like you talked about, right? A very small group, him and a couple of close friends. And in this case, his organization did not give him the resources, but he found them on his own, just using personal resources, time, a little bit of money, a lot of testing and experimentation. And eventually it blossomed into this huge, multi-billion-dollar success for the company.
I love that example. And it actually points out two things that I was going to bring up at some point in the conversation anyway. One is it was really poor of the C-suite to poo-poo it when they should have given him some time to experiment. Not unlimited time and not unlimited budget, but okay, try it out and let's see what happens. So that's the first thing is that's a really good example of why a lot of large companies aren't successful at innovation. They don't have the support that they need. The second point is he didn't stop, even though they said no. And that level of persistence, that's impressive. And that's exactly what it takes at time to really drive innovations through. And so don't give up just because somebody says no.
I love the word persistence that you used. I think that earlier I asked, is innovation reserved only for the cream of the crop, the most intelligent people out there? And I happen to think that success and innovation is much more about persistence than it is about brilliance. I think 9 times out of 10, maybe 99 times out of 100, it's the persistent person, not just the brilliant person that wins out there. I know I've seen that over and over. I don't consider myself to be the most brilliant engineer, not by a long shot, actually. But one thing I do think I'm good at is being persistent. I can continue to attack a problem, and I've definitely seen successes there where perhaps others who weren't as persistent would have failed.
I love that. I think that's a great way to put it. And I'll also stress that part of that persistence is knowing how to get help from others. Because, the C-suite says no, but, this guy over here, and it sounds like he did that. It was a small group of people and they tested probably a variety of different formulas before they found some that really resonated with their demographic. But trying to get that, and it's a small group of people. Another thing I really stress is never put a person on an innovation project that doesn't want to be there. If you're only putting him there because he's a mechanical engineer, they need a mechanical engineer, go help him out, and he doesn't want to do it, that's a recipe for failure. But so good. Okay.
I think that's another really important point that you make, that innovative projects are best staffed by people who are passionate about them. And I think I'd love to hear your feedback on this, but I think the reason for that is that innovation requires a lot of upfront time and often more time than the standard 40-hour work week can afford. And so it's typically the teams who are willing to put in extra time that they're not necessarily getting paid for, at least not up front. It's those teams. I think it's really required for a lot of innovative technologies. It's just it requires more time than the market at that point can afford. So people have to just spend extra time to get it going. Probably not 100% of the time. For a large organization with lots of resources, maybe not so much. But for smaller organizations, I think that's true. What are your feelings on that?
I completely agree with that, which is why, if you look at startup companies, they don't work 40-hour weeks.
Yeah.
They work 80-hour weeks, and they're not getting paid for 80 hours, but they love what they're doing, or they see that there's a really good future for it. And I don't think most of those people will say that they're in this because they want to be millionaires down the road, or they're going to, get multimillionaire stock option kind of stuff. They do it because they're really enthusiastic. They have this great idea. They want to prove that it really will work, and they're willing to put the time into it to make it successful.
Yeah. Yeah, that comes down to purpose, right? Do you have a compelling purpose for why you're doing something? And if you do, boy, that sure is a much greater motivator than just a paycheck, right?
That's right.
All right. Well, let's see. We talked a little bit about how large organizations sometimes can struggle with innovation because they aren't willing to provide the time and resources for a new disruptive idea to really take hold. How can a company know if they've sort of slipped into unknowingly the curse of the corporate business model? What are some of the warning signs?
Okay, so let's talk about what the curse of the corporate business model is. I classify it as sort of three things. And again, I'll pull up the book somewhere. I've got it here. So the first thing about the curse of the corporate business model is that in large corporations, multinational corporations, and we sort of mentioned this, investors measure the success of the company based on how well they're doing to deliver this month's profits and growth. And disruptive innovations that take a year or two or more to pan out aren't consistent with having to deliver results this month or this quarter. Now, there is a way around it. I'll get to that in a minute, but that's the first thing. The second thing is that the managers in a large corporation don't see the rewards being worth the risk. Now, what I mean there is that in a small startup, if you innovate successfully and that the startup goes IPO or gets bought out, you can become a multimillionaire. Doesn't happen very often, but at least it can. But in a corporation, if you're a leader that drives innovation successfully, you may get a few hundred stock options, you may get a promotion, but if that innovative idea doesn't pan out and you lose some money on it, your career is permanently damaged. And so a lot of managers in the corporate world don't feel like they want to take that risk, particularly since typically there's no penalty for not taking it. In the corporate world, you're not being measured by how much risk you're taking. You're being measured by, did you deliver this month's results? And the third part of this curse of the corporate business model is that a lot of the managers that are in large corporations are less prone to take risk anyway than the people that are in the small startups because of all of what I said there. And if you were in a large company and you love taking risks and you're not getting the opportunity to do so, you're going to leave that corporate environment and go start your own company. So those are the curse of the corporate business model and why, think of companies that are not successful or haven't been successful. Do you remember a company called Smith Corona? They used to make typewriters back in the days before word processing. You never hear about them anymore, but they were one of the prime manufacturers of typewriters. Palm, they didn't switch to the smartphone as the market evolved. And so your question about how do I know when a company is victim of the curse of the corporate business model is because they're going down the tube. They're not continuing to grow. They're not going after those new markets. And it's sort of by the time you discover that, it's too late usually to fix things.
They're still trying to make a better steam engine.
They're still trying to make a better steam engine. Great point. Yes.
I love that analogy. That just, it illustrates it so clearly for me. I'm not sure I've heard it, explained so clearly before. So that was going to stick with me.
I actually, spoke with there's a professor at the University of Kennesaw that, wrote his whole, master's thesis or PhD, dissertation on the transition from steam to diesel. And so I picked his brain and he helped me with the chapter I wrote on that. Because I didn't know what I knew that steam engines were no longer around anymore, but I didn't know all of the story behind it. And it's really an enlightening story. There were steps all along the way for about 20 years where any of those steam locomotive manufacturers, if they had just taken the right step, they could have been still the leaders, but none of them did that.
Do you know Clayton Christensen?
Oh, yeah.
Yeah, okay. So his book...
Clayton Christensen.
Right, yes. I can't remember the exact title of the book, the Innovator's Dilemma or Disruptors, something like that. But he talked about something similar where hard drive companies, right, were disrupted by solid state drives and how they couldn't really catch up.
That was another good example. And I figured he'd already did that one. He had also used an example, I think in the same book, about steam shovels being replaced by diesel shovels. So I didn't want to rehash those examples in my book. And I thought, well, why didn't he talk about steam locomotives? That seemed like a perfect example. But since he hadn't talked about it, I thought I would.
Terrific. Well, I'm glad you did. Let's talk about AI a little bit. AI is just, it's the next huge thing and has the potential to really revolutionize not just the way that we work, but the way that we live, and in some cases already is. How should engineering, manufacturing, technology companies be utilizing AI? And how are some companies maybe misusing it?
So, a couple of points here. First is there's a lot of hype around AI that is probably being promoted more by people that want to make a lot of money off of it, as opposed to by the fact that it's really going to help in certain areas. So you got to be careful about that. But I do believe it really has a place. But you've sort of got to learn to walk before you can run, kind of thing. You can't use AI yet to come up with the next disruptive innovation. AI, from what I can tell and what I've seen and how I've talked with people that use it, it can be very effective at some of the lower level kinds of analysis of data, of being able to track things that are going on at sort of a regular level, and this stuff that if it does something wrong, it's not going to drive your company to bankruptcy. I still do a lot of consulting work for TeamLogic IT, and one of the key things that we do for our customers is we're continually monitoring their IT networks and immediately detecting if something is wrong. If a server goes down or if there's malware coming in, the idea is that we're running software on their network that tracks this and can immediately notify us that there's a problem. Now, 5 years ago, that meant that a technician in front of a screen was getting a notice that said, there's something going on with the server, you better check into it. Now, AI can look at these kinds of things and immediately say, okay, here's what's going on. This is what I need to do to fix it. And they don't ever have to even involve a technician for routine stuff. And if it's something that is not routine, then the AI process can escalate it so that that's the kind of stuff that the real technician needs to work on. But AI can eliminate what used to be a real time sink. I used to have 3 first-level technicians sitting in front of screens all the time, just watching all of my clients' networks to figure out what needed to be fixed or if something was haywire was going on. And now a lot of that can be done automatically. So that's a good way of using AI in a way that is effective in now. Now, I can't say that I know how a company like HP in their R&D environment is using AI. I mean, AI is good at writing software, but it's not great at writing software code without bugs in it. So you can generally use AI to give yourself a first draft of code to do something, but then you've got to have an engineer look through it and make sure that it is really doing everything that you think it is without a bunch of gaps or things left open where hackers can break in, that kind of thing. So AI is still good at the lower level stuff. And maybe in future years, it'll be better at moving up in the food chain to higher in the environment. But I don't think it's there yet.
Yeah, agreed. I use it a lot because I do a lot of marketing and sales and writing and communication, and it's great for that, but it's not going to develop a new CAD model for the machine that we're trying to design right now. Not yet.
That's
anyway.
Right. Yep. And my son is the chief technology officer of a little bit more than a startup now in the AI area. They're providing. He lives in England, and they're providing a AI technology for the European banking industry, which is, you got to be careful. That's there because you screw up in the banking industry. And he says, we're very careful about what we do use AI for. In fact, the European Union refuses to let him use any kind of AI where the large language models are stored in the United States.
Oh, interesting.
Because they don't trust that the security protection is there. So he's had to set up his own large language model in Amazon Web Services that allows him to provide services that he would not otherwise be able to provide.
Yeah. Well, let's see, Steve. Let's do just a couple more questions here, and then we'll wrap things up. For engineers who want to move into leadership, what are some things that they should start doing now to build a innovation-focused career?
So it's easy for engineers to just focus on whatever code they're being asked to write right now or whatever circuit design they're supposed to do. And, just keep their head down and do what they're being asked to do. If you want to move higher into the organization, into leadership roles, you've got to think beyond that. You've got to understand, what is this business that I'm in? And try to understand how the leaders of that business are thinking and where they set their priorities, and sort of understand, why are they doing it this way, and have discussions with them. You got to be a little careful about that, because not every manager is comfortable with that kind of thing. He's going to feel like, why are you questioning me about the decision I made? But a lot of them, they'll love to see an engineer, first level kind of individual contributor who is showing more interest in what the business is all about, because they know that those are the kind of people that will have the innovative ideas that can drive that business even further. So that's really important. Understand the business, and then, as I did, understand not just R&D, but learn about what is it like to be in marketing. It doesn't mean you have to move into marketing. You can work closely with the R&D, the marketing counterparts that are launching the products that you're inventing. But learn more about the whole business than just the part that you're in. I think those are a couple of key points that engineers just getting into their career should understand.
I really like your point about understanding the business, because, businesses don't exist to do engineering or to do manufacturing or even to do innovation. Businesses exist to make a profit. And that's the only way the business can remain in business and employ all the wonderful engineers and others who work therein. And so for engineers to understand the business, it really just allows them to contribute in a much more meaningful way to the purpose of the business. I know that we've had engineers on our team in the past that have been just wonderful, wonderful human beings. I've loved working with them, but ultimately they couldn't do the work effectively enough for the company to be profitable on their time. And, those engineers, they don't last long term.
That's right.
So understanding the business, what the business needs and how your direct contributions, can support and facilitate those business outcomes it's huge.
And that's especially important in today's climate where things are changing rapidly. And the knowledge that you have today and the understanding of how to do things today may not be sufficient for 3 or 4 or 5 years down the road. The more AI comes in, or maybe there'll be some other new hot topic 3 years from now that you need to stay aware of how business is evolving and what it takes to stay relevant as markets are evolving as well.
Yeah. Well, Steve, last question I have for you. What is one thing that you've done or seen to accelerate the speed of engineering?
The thing that I've done is in a leadership role, not as an engineer. In a leadership role, my job is creating an environment that makes the engineers feel like they are supported and that they have the authority to do what they think is right. That may not be what I think I would have done if I was in their shoe, but I give them the flexibility to do things the way they think is right. And that doesn't mean it'll work out all the time. Sometimes it'll not work out, but that'll be a learning experience for both of us. And it'll make them better engineers in the future if they are feeling like they have the flexibility to do things the way they want to, as opposed to only doing things the way I'm telling them to do.
Any tactical recommendations that you can share or specific practices that you've implemented to create that environment where engineers feel safe and empowered to do the right things? So
again, it sort of, my role as the manager is not to be the best engineer. My job is to give them that environment. And so a lot of my job is to work with higher management to keep those higher managers out of the way so that my engineers can do what they need to do. And so in the book, I give an example where I needed to give my engineers time to invent something new before top management shut us down. And so I spent, close to a year where pretty much all my job was putting together financial forecasts and order forecasts that said, this is what we're going to do. And this is why you should need to keep us open long enough for those engineers. So the engineers were happy. I was not telling them what to do, but I was keeping the higher management off of their necks. And so that buffer between higher management and the engineers doing the work is a key thing that a good manager should be able to do.
That's a great example. I bet not many people would think of something like that, just the fact that that's a necessary and critical part of the business. But great example. Thank you for sharing that. Well, Steve, this has been delightful. How can people get in touch with you?
So I've got a website. It's www.stephen, STEPHEN, -W, Hinch, HINCH.com. And the publishing company also has a website, atenera.com, ATENERA.com. Either of those two websites are easy ways to get a hold of me. I also have a LinkedIn page. You can search me on LinkedIn and communicate with me that way. And I'm happy to have conversations and answer any kind of questions, give any kind of coaching advice that people may have.
Awesome. Well, we will include those links in the show notes. And Steve, thank you so much for spending some time with us today. What a fun conversation this has been. You just have a plethora of experience and wisdom. And thank you for contributing to this body of knowledge in the Being an Engineer podcast and sharing all of that experience and wisdom with us.
Thank you very much. I appreciate it.
I'm Aaron Moncur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services, visit us at teampipeline.us. To join a vibrant community of engineers online, visit thewave.engineer. Thank you for listening.